Part 3. It's time to talk about why is momentum conserved in a system when the external forces, the sum of all the external forces acting on the system, is zero. Well, this is not something that's unique to momentum. It's actually not something that's unique to energy. It's actually take anything that's durable, that can't really spontaneously come into existence, can't really be destroyed. In class, I talked about just poker chips just because they happen to be there. So let's just keep that example going. So when would the number of poker chips in a system be conserved? So in this example on the left, I have, let's say I have, this guy has 3 poker chips, this guy has 7, just making these up, and she has 1. And then time goes by, and we can see that these people are interacting. In this context, interacting means, hey, they're maybe giving each other poker chips, maybe taking poker. Well, someone can't give a poker chip without someone taking a poker chip. So let's see, the total number here is 11, and time goes by, and we see that this is a closed system, meaning there's nobody that's going to take a poker chip from anybody in this system, and there's nobody that's going to give one. And let's suppose later on I see that this guy has 4 and she has 3, and now we know how many this guy has really, because we know that in a closed system the number of poker chips can't change. So we know the total is 11, so this guy must have 4. And we can keep going, and let's suppose that she ends up with 10 and this guy ends up with 1. Then we know with really absolute certainty that this guy's going to have none, because there's just no way for the number of poker chips in our closed system to change. Now notice one thing that can happen though is there can be these internal interactions. And it is absolutely possible that the number of poker chips held by any one of these 3 people will change. And that's not what we're saying. We're not saying that the number of poker chips held by one person will be the same. It's that the total number of poker chips in a closed system will not change if the system can be considered to be closed. Let's contrast that with an open system. I think you see where we're going here. Is this guy has 3, she has 10, he has 4, getting to be more for whatever reason. Now there's 17, and the passage of time goes by, but in the interim there is this outside delivery of, let's say we don't know how many poker chips, but we know that there was either some taken out or given. And then of course we lose all visibility of who has how many poker chips, what's the total number of poker chips, because in an open system the total number of poker chips in a system can change. Okay, is there ever a situation in an open system where the number of poker chips will still remain constant? And maybe you already see where this is going. He has 1, she has 2, he has 4. And let's see, what's that? That's 7. And in the interim, there's passage of time, and we say, oh my goodness, somebody delivered X number of chips, and we don't know what X is. But if we can be confident that during the same time interval, that the same exact number of chips was taken away, then we still know that the total number is going to be 7. Now we may not know, in fact it's possible we won't know what the distribution is of the poker chips within the system, but we know so long as the number coming in whatever this quantity is, and the number going out is the same, then the total number of poker chips won't change.